All right, welcome to 7.2 basic probability rules, which cannot be spelled properly. So that's not my fault. Um, yeah, I don't know. I just now noticed that. Anyway, uh, probability model. Probability model, a description of some chance process that consists of two parts. A list of all, hold on, gotta get the color ready. Let's go with purple. A list of all possible outcomes and the probability of each outcome. Probability of each outcome. Well, of course, we'll make some of these today. You'll know what they are, but here's our kind of definition, right? Sample space, a list of, well, you got this one, all possible outcomes. Event, any collection of outcomes for some chance process. Okay, moving on over here. Probability of equally likely outcomes. So you kind of already know this, but it's nice to have it written down. Probability of A is just going to represent an event. So probability of some event is the total number of outcomes in that event divided by the total number of outcomes in the sample space. So for example, if you remember back in the 7.1, we were talking about the probability of rolling an 8, right? For the game of craps. And I made a little chart for you, and I showed you that there are 36 possible ways to roll the dice. That would be the denominator, total number of outcomes in a sample space. There are 36 ways to roll 2 dice. And then the number of outcomes in the event, the number of outcomes of rolling an 8 was, remember, 5. There are 5 ways to roll an 8. So there are 5 total ways of rolling an 8 out of 36 total ways in general of rolling a die. So that's kind of what this probability is. We've seen before. The complement rule. We've talked about complement, right? We've done it with the last unit. Probability of A complement is 1 minus the probability of A. So if A, let's say whatever event A is, right? If A has a 20% chance of occurring, then the probability of not A is an 80% chance of occurring. Exactly, right? 20% chance that it does occur means it's 80% chance it doesn't occur. If you look at the probability of rolling an 8, remember we said rolling an 8, there was a 5 out of 36 chance of rolling an 8. Well, that means if 8's complement, hold on, stupid bell. The complement of that would be a 31 out of 36 chance of not rolling an 8, right? 31 out of 36 chance of not rolling an 8. That's the complement rule. So, yeah. So the probability of the event does not happen. Okay. Mutually exclusive. If they have no outcomes in common and so can never occur together. That's a weirdly phrased sentence. If they have no outcomes in common and so can never occur together. So the probability of A and B equals 0. Let me think about an example of this. Hmm, I don't know. I'll come across one later. Addition rule for the mutually exclusive events A or B is the probability of A plus the probability of B. I'm sure we'll run into some examples, so we'll get to that. We'll get to that. But for now, we'll come back. We'll come back to this. All right. Example A. Suppose you spin a spinner with 3 equal sections, red, blue, and yellow, 2 times. Give a probability model for this chance process. Okay. So, wish there was a little bit more room, but we're gonna make it work. So normally the way a probability model would work is you'll have the event or the outcome over here, and then its probability over here. Now we're gonna need a little bit more room here, but let's figure this out. So I'm gonna spin the spinner twice, right? I need to list all the possible outcomes that it could happen. So I could spin it the first time and get red, second time could be red. So I'm gonna put one outcome as red, right? Now we'll talk about the probability of that occurring in a moment. But another outcome could be red, blue, right? I could spin red first, blue second. I could do red first and yellow second, right? I could also maybe do blue, then red, blue, then blue. I'm gonna continue this over here. So, because this is what I was complaining about not having enough space. Just gonna imagine that this was below it, right? Blue and blue, blue and yellow. Or what about it could be yellow and red, or yellow and blue, or even yellow and yellow. All right, so how many outcomes were there? There are total here five, four. There's 9 total outcomes, and they're all equally as likely as occurring. So the probability of each one of these is 1/9, 1/9, 1/9, 1/9, 1/9, 1/9, 1/9, 1/9, etc., etc. This is a probability model. It shows all the probability outcomes and their probability of occurring. Right? Normally it's one column. So again, you could just kind of imagine that I put this below here and just kind of had it dragged down. But obviously I ran out of room. So I just got moved it over there. All right. So don't mind. Normally it's not broken up in this way, but just ignore that. Anyway, that's a probability model. Congratulations. Define event A as spinning a blue at least once. Ooh, okay. So how many outcomes involve spinning a blue at least once? So we have one here. Right, let me see if I can highlight these. Once there's a blue here, a blue here, a blue here, and a blue here. So probability of spinning a blue at least once, there are 5 ways to do that, right? 5 outcomes with at least one blue, right? And I'll list them. They were red, blue, blue, red, blue, 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 yellow, and yellow, blue. All right. So the probability of A being, again, spinning a blue at least once, is a 5 out of 9 chance, right? Because remember, there's 9 ways to have the outcome occur in total, but 5 of those 9 ways, as you can see up here, are containing a blue. So 5 out of 9 chance of containing a blue, which is roughly equal to 0.55 probability, about 55%. If the 5, 5 repeats. So it's just 5, 5, 5, 5, 5, 5, 5. Right. Moving on over here. Miss Chauvet keeps a mystery box in her classroom. If students meet expectations for behavior, they are allowed to draw a slip of paper without looking. The slips are all equal size, well mixed, and have the name of a prize written on them. Here is the probability model for the prizes a student can win. All right, so again, probability model. So you have all the possible outcomes and then the probability of selecting one of those outcomes. So we have a 40% chance of winning a pencil, 25% chance of winning some candy, 15% chance of some stickers, 15% chance of getting a homework pass, and then even a 5% chance of some extra recess time. Explain why this is a valid probability model. Well, here's what we need to be a valid probability model. This means right here, we're looking for probability adds up to 1. Probability should always be a total of 1. So if you add these all up, 0.40 plus 0.25 plus 0.15 plus 0.15 plus 0.05, guess what that equals? It equals 1. So that's why it's a valid probability model, because it equals 1. All right. Find the probability that a student won't win extra recess time. So the way I would say this is probability of recess, right, equals 0.05. But the probability of no recess, or not no recess, but not extra recess, is going to be 1 minus the probability of recess. So if recess has a 5% chance of being selected, I'm kind of overworking this problem, then there's of course a 95% chance of not winning that. So a 95% chance of getting something else. So this is that complement rule that we were talking about before. So 95% chance of not getting extra recess. There we go. Very nice. All right. Final example down here. According to a recent US Census Bureau data, the number of people in US households have the following probability model. So we have a number of people who live in the house. We got one, we got two people living in the house, three people living in the house, 4, 5, 6, 7, etc. So, and then of course the probability of each of those. So yeah, 28% of houses have only one person living in them. 34% of houses have two, 16% of houses have three people living in them, etc., etc. That's what we're going on here. Suppose that a household of 5 or more people is considered a large household. Randomly select a US household. Oh, that was it. Randomly select the US household. Great. Find the probability that the number of people in the household is 4 or fewer. So the probability of 4 or fewer is going to be equal to the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability of 4, right? 4 or fewer is going to be obviously all of these added together. So in this case, 0.28 plus 0.34 plus 0.16 plus 0.13, which is equal to 0.91. Now, another way of doing it is 4 or fewer would be not 5 or more, right? So if you found the probability of 5 or more, you add these three together, it'd be the opposite of that. So like 5 or more is 6 plus 2 plus 1. That'd be 9%, 0.09. 4 or less would be the opposite of that. So, you know, if there's a 9% chance of 5 or more, then there's a 91% chance of 4 or less. So that's another way of looking at it, right? Kind of just wanted to point that out. Find the probability that the chosen household is a large household. So remember, defined a large household is 5 or more. So probability of a large household is defined as the probability of 5 or more. So probability of 5 plus probability of 6 plus probability of 7, which is what we kind of just talked about. 0.06 plus 0.02 plus 0.01, which is 0.09. But also at the same time, just to point out, it would be the opposite of 4 or less. So this would also equal probability, or I'm sorry, 1 minus the probability of 4 or fewer, which is 1 minus 0.91, which is still 0.09. So there's, like I said, there's two ways you could have calculated that answer. You know, however you want to math it out, it's up to you, but it's the same thing here, right? Just wanted to make sure you understood that. All right, but I think that's it for this section, 7.2. So I'll end it here and I'll see you guys in 7.3. Bye for now.